Hello friends, welcome to my channel. Let's have a look at problem 236, lowest common ancestor of a binary tree. In this video, we're going to give a treatment based on traversal. We're going to share two formats of solutions. One is in iterative format, and the other is recursion. So this problem actually is a very classic problem now. First, I'll read through the problem statement to digest the requirement, and then we do the analysis, and finally we share the two formats of code. So first, the problem statement. Given a binary tree, find the lowest common ancestor, so LCA, of two given nodes in the tree. So here is a definition of LCA. So here are several examples. So in example 1, so the two nodes are 5 and 1. So 5 and 1. So their LCA is the root 3. In example 2, so the two nodes are 5 and 4. So because 4 is a descendant of 5, so 5 is the LCA. So in example 3, so the P and Q are 1 and 2. So because 1 is the root, is also one of the PQ. So we return 1. So the constraints are actually also important for us in this problem. The first one is not that essential. This one actually determines the problem size. So notice that the number of nodes is bounded above by 10 to the power 5. So the second one is about the range of node values. And the third one is important. It says that the node values are unique. So this is very important, right? So the fourth one is also important. P and Q are not equal. So if they are equal, we just need to return one of them. So P and Q will exist in the tree. So this is also an important one. So in the sense that this provides consistency. So with that said, we are ready to do the analysis. So as we mentioned, we're going to share one treatment, two formats. So the treatment actually is traversal, right? So we have actually practiced quite a lot on binary tree traversal or graph traversals. So either breadth first search or depth first search, or in-order traversal, post-order traversal, or pre-order traversal, and so on. So the first method will be an iterative traversal method. So and the second method will be the recursion method by the very definition of LCA. So the first method is to help build intuition. So in this method, we find the node parent chain, and then we locate the LCA, right? So for example, let's use first example 1 as example. So here 5. So the 5 then up to the node, from the node to the 5. So we get 5 and 3 if we traverse upwards. Then for Q is 1, so we get 1, 3. So if we start from the nodes upwards to the node, so we want to find the first same one, that is 3. If we do it reverse, we want to find the last same one, that is also 3. So let's look at example 2. So in example 2, P and Q are 5 and 4 respectively. So the parent chain is like this, 5 to 3. And for Q, so it's 4 to 2 to 5 to 3. So the first same one in the two chains actually is 5. So we're going to return 5. So similarly, this example is sort of special because 4 is an offspring of 5. So we return 5. So if we look at the P is 6 and the Q is 4. So the chain from 6 to the root or the path is 6, 5, and 3. And the chain from 4 to the root is 4, 2, 5, 3. So if we look at this arrow direction, we want to find the first same one, that is 5. So if we want to look from the root to the node, so we want to examine the last same one. The first same one is 3, and the second and the last one is 5, right? So we return 5. So this is the first method. The second method actually is based on the intuition we gain from the first method. So we just need to use definition of LCA. So if the root is one of PQ, we just need to return the root. So if both P and Q are in the root left, so we are going to look at the left subtree. Similarly, we are going to look at the right subtree. So if one of the two is in left subtree and the other in the right subtree, so then the root is the LC by definition. That's it. So here we want to first make a comment on the extension or connection. So actually the first method has a connection with the UniFind. So for the node parent chain trick, it mimics the find method in UniFind trick or the disjoint set union abstract data type. So you can check out the UniFind playlist in my channel to gain more techniques or establish this connection. So with that said, first let me write the solution V1 using the chain, right? So V1 is node parent chain. So for this, I'm going to use a dictionary. So no, though it's not absolutely necessary. So this just to help us to establish intuition for version 2 of solutions. So for this, I'm going to use a root. So the root, as we know, so for the by the constraint, the full tree rooted at the root is not empty. So we can use this root as null. And then I'm going to use a stack to do a traversal in an iterative format. So for this, I'm going to use a pre-order traversal. So you can use actually different orders. That's not essential. So also I'm going to use early stopping. So in other words, if both P and Q are in the roots dictionary, so which records the parent node parent relation, so we stop, right? This is the stop condition. So we don't need to do further traversal as we see both P and Q. So here, this condition actually is a while loop. We just translate so a while condition. So if P not in roots or Q not in roots, so this is the condition that we continue to do the traversal, right? So in this case, we can first get the node, that is pop, right? Then we are going to check the right subtree first, and then we try to check the left subtree. So this order corresponds to pre-order traversal. So then if node right, so then we're going to add this one to the stack. So node right, and also we record the parent and the node parent relation, right? So node right equals node. So similarly, let's check the left subtree. So for this, we can copy this part. So if node left, so here left, here left. So that's it. So if we do not store this line here or this line here, that's nothing but the standard traversal, right? So once we record this node parent relation in the process, we could easily get the chain, right? So this is the traversal step. So next, let me get the P chain. So here actually I can use a set. So the reason is that all the nodes values are unique, right? So with that said, I can set a parent that is a P, right? So while current, and then what we are going to do is we add the thing to the set, right? Then we look at the parent, that is roots current. So this is nothing but the way we find the root in the find method in the disjoint set union method or abstracted type, right? So once we done this, this is the case. So let me do this. Yeah. So once we get out of this while loop, so we stopped at the root, right? Because the root have parent now. So with that said, then we're also going to traverse from the queue, right? So let's reset the current to be queue. So we want to find the first common one in the two chains. So this is another while loop. While current, so actually we can check if current in p chain. So we just need to return, right? So otherwise, so what we're going to do is that, so we're going to traverse above. So that's current. So as we exit this, we should have already returned. So otherwise, we just let's see, return current. So this is sort of redundant, right? So this is one solution, right? So now let's do a check first. Yeah, it passes the first example, I guess. So now let's look at the generic case. Yeah, it passes the generic case. So now let's look at the second version. So here I'm going to copy this function signature, right? So I'm going to put it here. And then what I'm going to do is that I will want to use recursion. So actually it's the same logic as above, but in a compact version. So here what I'm going to do is the following. So we're going to check whether the tree rooted at root contains P or Q. So if it contains neither P or Q, so we return null. Otherwise, so we return LCA. So this is the problem requirement, right? So here now let's translate the above logic as we specified here into code format. So that's actually very easy. So first I'm going to do is that I'm going to check if root is null. So notice that in the problem setting, this node, so as the full tree, is not empty, right? So, but you know, this is important. This is the stop condition or base case for our recursion. So we're going to return null. So this is the one. And then we are going to look at the left subtree and the right subtree, right? So the left subtree is the we're going to look at root left and PQ. And the right subtree, we're going to look at the right subtree result. So then the logic is here. So if left subtree contains one of PQ and right subtree contains one of PQ. In other words, both are not null. Then we know the current root is the LCA. Or another case is that so root as a value, so root value, so in P value or Q value. This we use again that the values of the nodes are unique, and then in this case we are going to return root. So otherwise, so it means that either left subtree or right subtree contains both P and Q. Then we look at the corresponding tree, or we did both contains none of P and Q, right? So then we just need to return a left result or right result. So here, I guess the use of this logical operation is important. So with that said, we use this code to encode the problem requirement. So I'm going to call this one version 1 so that we can check this solution. First, let's look at the special case. It passes the first example here. So now let's look at the second, the generic case. Yeah, it passes all the generic cases. So I guess that with the second version finished, that's about it for this problem itself. As we mentioned in the extension or connection, it's good to look at the version 1 here. So this version actually tells us the details, and then you're welcome to check out the unified trick, especially the find method, to fill or grasp the connection or similarity between the chain node parent chain method and the find method there. So with that said, I guess that's about it for this video. Thank you.